Hello ladies and gentlemen, today we have another super chill, super calm tutorial for you guys. In the previous episode, we got shooting working. So we have a really basic shooting system. Currently we can move around, rotate our player, and we can shoot, so that's pretty cool. In today's episode, we're going to be doing collisions for our movement. Because movement's great and all, but we don't want our player walking through walls. So that's what we're going to be covering. First thing we're going to do is, we'll get straight into it, is just make a sprite for a wall. Did you guys hear my stomach grumble then? Alright, we'll just do a 64 by 64 block. We can make it any color we like. I'm going to just make it orange. I feel like orange today. So we go for orange. We're also going to make a wall object. I'm just going to call it obj wall. And I'm going to give it the orange sprite. We can stick our wall in to our room. We can put a few walls. If you hold Alt key down while you're in the room editor and you've got it selected, you can actually just click to place walls, which is quite cool. You can also, instead of placing multiple walls like this, you can also just stretch walls. So I'll just make a little sort of map. Why not? Might as well make a little map while we're here. Nothing too fancy. Grab the corners, something like this. Why not? Why not? There we go. This is our this is our level. Looks alright. Alright. So for our wall object, we actually don't have to do much at all. The only thing we've got to do for this object is we've got to create a parent object for it. And what a parent is, we're going to make this thing parent wall. And what a parent is in general, children inherit from their parents. Kind of like in real life if your parents die. Alright, so object wall will inherit from parent wall. And what that means is that anything that parent wall can do, object wall can do. And the reason we'd want to do that is because we might have multiple different wall objects later, but we want them to all behave sort of like a wall. We want them to be a wall. But we don't want to have to rewrite code and we don't have to write a collision code for every single type of wall. We'd just rather write one bit of collision code for the parent wall, and then it will just work for every single wall. So that's what we're going to do. To add a parent to object wall, you come down here, parent, and you just select. We just have parent wall. You don't have to give parent wall a sprite or anything. It doesn't really matter. We're just going to give it parent wall. And now in our player code, we can check for a collision with parent wall. Alright, so if we come in here, we need to change our movement code. So currently we're just adding X or Y. All we got to do is add a check in here to check whether or not we can actually do this move. Like whether we can horizontally move, and if we can vertically move. And if we can, we do move. That's going to be the basis of it. It'll be a little bit more complicated, but it's probably the most complicated code we're going to see in a little while in this tutorial. I'm trying to keep it really simple. We're going to use if place meeting. So what place meeting is place meeting, what it essentially does, I can actually bring up the documentation if you want to have a look, is essentially moves the sprite or moves the hitbox of your current object and then checks whether there's a collision or not. So this is really good for movement because we want to check if we will be colliding when we move. And if we will be colliding, then we don't want to move. This is really good. And so we want to check if there is, I'll use the not sign. So if you put an exclamation mark before a function like this in an if statement, this just means not. So if we're not place meeting, and in the place meeting we have to put the place that we're checking, and we have to put the object that we're checking for, which will be the parent wall. I'll just show you guys really quick. We're gonna do it in two parts. So one's gonna be for horizontal and one's gonna be for vertical. So I've just put a bunch of spaces here so you can see it really clear. If you guys do have any questions as well, please ask in the comments. I will be super active. This is a little confusing, but what we're gonna do is we're going to, so we have x plus equals horizontal movement plus times m speed. We could actually make a new variable, call it x move amount. And we're just going to make that equal to what we got here. Might make it a little simpler. So our x move amount equals horizontal movement times move speed. And that's how much we want our character to move in theory. That just makes it a little bit simpler here. And then what we can do is we check whether or not there's a wall at x plus that amount that we're moving. Or the amount that we want to move, I should say. And we're checking for parent wall, just like that. If there's not a place meeting, so if there's not a collision in the place that we want to go, then we move. That's all this does. If it's not a horizontal, there's not a place meeting in the horizontal, then we move our horizontal amount. All right, awesome. We'll do the same for the vertical. If you press Control D as well, you can duplicate lines, so don't forget that. It's really, really useful. So let's just yoink this. And we will just, I'm just gonna do some copy pasting here. So this is for the horizontal collisions. And this is for the vertical collisions. Just like that. We need to change this a little bit. So instead of checking this here, we need to check when we're at the new y position. So x is the same and y is going to be y plus y move amount. Good way to think of this is that if y is a positive amount, which means we're moving downwards, then this is going to be the correct position. Also, if it's a negative amount, then we're adding a negative and it's going to check above us. So this should work for really basic collisions. We will be making this a little bit more complicated in a second because I'll show you the issue with this. But if we run this, if I didn't make any mistakes, we should just off the bat have, you will probably, if you run this in your own code, you'll immediately see the issues. There's a couple of issues we have to fix, but you can see very basic collisions. It's a bit janky though. So we're going to have to do a couple of fixes. So the first thing we're going to have to do is to do with actually the sprite and the hitbox. So if you look at the collision mask, there's kind of an issue with the axis being off. Because when our image rotates, the collision mask also rotates. And so what's happening is that when I rotate my player, the collision mask is rotating, and you're going to get this issue where you can get stuck in walls or it's not going to be colliding consistently. So we want the collision mask to be consistent. I'm actually just going to make a completely new sprite for the collision mask. We'll just call it sprite player collision mask. I'll try sprite. I'll just call it mask underscore player. Maybe that's smarter. Call it mask underscore player. And we will do, we'll do it a little bit smaller than the character. I think that'll turn out a little bit better. So we'll do it a 48 by 48 pixel here. You can do whatever you want. You can do it the same size as your character. And we're also going to use a square for the time being. Ideally, Jesus Christ, these colors are very strong. Ideally, we have like a circular collision. Not necessarily, it kind of depends what you want, but this basic collision system, one of the flaws with it is that it won't allow for sliding along walls. it does allow for horizontal and vertical sliding, but it doesn't allow for diagonal walls. So while we have these square walls, this will work fine. Later on, if we have diagonal walls and we want our character to actually slide, so if I run into a diagonal and want it to automatically slide along it, we will have to change the code a little bit. We might do that in a future video. For now, we're going to keep it kind of simple. And we're going to, I'm actually going to edit this sprite as well, which this is the sprite that we're going to draw. And I'm just going to make the axis in the center. So the axis that the sprite rotates around is going to be in the center, and we can actually offset the player as well a little bit. So it'll be 1 second. So I'm going to resize the canvas. I'll make it a bit bigger. Why not? We'll make it 96 by 96. It's quite large, but it's fine. I'll make it in the middle center, and then I can edit the image, and I can use my arrow keys here. Basically adjust this so that the axis of rotation is closer to the center of the sprite, which is what we want. And in this player idle, this is what's getting drawn, but we don't actually care at all about the collision mask. So this is our collision mask here. And we'll put it in the middle center as well, the orientation. And for the time being, just to show you guys the collision system properly, I'm just going to change the sprite of the player to the mask. We're just going to flat out, oh, ignore that. We're just going to flat out, I don't know why I spam save so much, it's like OCD or something, but I'm just going to change this to this blue rectangle just so you guys can see it a bit better. And we're also going to change it so that the image angle is not actually changing. So changing the image angle actually changes the angle of the collision mask, and we don't want that. So we're actually going to add a new variable. Don't add var, because we want it to be like a public variable. Angle equals 0. We're just going to declare this new variable angle. And then we're going to, in here, instead of changing the image angle, we're just going to change the angle. Angle equals angle to mouse. Awesome. And then we're going to, since the image angle stays the same, when we fire the bullet, we just want the bullet to be set to the angle. Let me see how I've done this. This might actually be fine. Yeah, I'm actually not using the image angle in the bullet firing, so it's actually fine. Don't have to change that. We're just adding this new angle. Now, if we run the code, we should be a blue rectangle. Awesome. And you can see we collide with the walls. You will see an issue currently where there'll be a gap between, you can probably see that slightly. If I increase the speed, let's just make it really high. Let's make it like 15. You'll probably see it's a bit better where there is a slight gap. And the reason is that we're checking every 15 pixels whether there's going to be a collision. And then if there is going to be a collision, we just don't move at all. So we need to fix that. And the way we're going to do that is to, if we detect that there is a collision, we're going to incrementally move our player over until it is touching the wall. And I'll show you exactly what that looks like. That's going to fix this issue here. So if we go in the step function, if there's no collision, we're just going to move. But if there is a collision, so it's an else. So if there's no collision, move. If there else, which means if it's not, so if there is a collision, then we're going to have to do an incremental move. And what this looks like is we're actually going to use a while statement. So a while just keeps looping while the thing inside is true. The thing inside the brackets here. So while there's no collision, actually copy paste this. While there's no collision, at x plus, what we want to do is we actually want to, it's going to be a little bit of you might need to ask in the comments, boys. I'm rushing a little bit. I'll try not to rush. It's supposed to be a chill tutorial. I'm covering a fair bit of new stuff you guys might not have seen before. We're also using this sine function. So I'll explain what the sine function does really quickly. The sine function returns, it probably says here, it returns either a 1 or a -1, or a 0 actually, depending on the number that you give it. And so if it's a positive number, it returns a 1. If it's a negative number, it returns a -1. And if it's a 0, it returns a 0, which is quite useful. It's really, really useful. The reason it's useful is that what we can do is while there's no collision, I'm trying to think if this works. So if there is a collision, then we're going to, while there's no collision, moving a single pixel, because if we're moving to the right, sine of x move amount is going to be a 1, which is 1 pixel to the right. And if x move amount is a negative number, which means we're moving to the left, then we're checking 1 pixel to the left. So we just we're going to do this while loop and keep checking 1 pixel over until we hit a wall. And if we do hit a wall, then this won't be true anymore, because not place meeting will be true, not place meeting will be false. So it will end the while loop and we'll be in the correct position. So while I hope it's not too confusing. I hope you guys are following. So while not place meeting, we want to move 1 pixel. So we just are pretty much doing this. So x plus equals whichever direction we need to go. That's plus minus. That doesn't do anything. Yeah. All right. So x plus equals sine of x move amount. And that should work fine. And then we're going to just do the same thing. I'm just going to copy paste this. We just do the same thing for the y axis. So while place meeting, okay, so we just going to check our current x. And we're going to check our new y. And this will be the sine of the y move amount instead of the x move amount. And this is going to be y. Just change all these x's to y's pretty much, except for this one. So this should be, again, we're doing the same thing with the vertical collisions. If there's no collision where we want to move to, which is y, our current position plus the amount that we're trying to move, if there's no collision there, we just do the movement. I can actually change this to move amount. We don't need to, because move amount is equal to vert movement times m speed. If you guys don't remember what vert movement is, it just returns a 1 if we're moving to the right, and a -1 if we're moving to the left, or a 0 if we're not moving, or we're not trying to move. It's based on the keyboard inputs here. Okay, awesome. So y plus equals the move amount if there's no issue doing that. If there is an issue and there is a wall at the place we're trying to move, we're going to incrementally move towards that wall. So we check while there's no place meeting. So while there's a free spot 1 pixel to either the below or above, depending on which direction we're trying to move, then we're going to move that 1 pixel. And this should work. I am a believer. So you can see here, still should. It's very fast. You can see even though we're moving really fast, the collisions are actually just completely perfect. Like really, really nice. Again, there would still be some issues with diagonal walls and such. We'll have to address later, but for now, we're just going to stick with this. We can just use the square walls. And you can slide along the square walls like this. So it is looking pretty good. I'll change the speed down a little bit. It's a little bit excessive. Let's go like 5. 5 should be fine. I'm pretty sure this will also work with decimal points as well, which is good. Yeah, I don't think you'll have any issue with like 5.3 move speed. Yeah, it looks fine. Yeah, let's just go. I'm used to the fast now. I'm going to use 7. We'll go 7. Beautiful number, just random number that we like. Set your numbers to whatever you want, guys. We're trying to make the system, when you're coding a game especially, try and make a system where it's not going to break at certain numbers. It's just, like, you should be able to have the speed whatever you want, right? So this system here will work for any speed, which is really good. The only time this won't work is if the speed is really, really high. If the speed is too high, it will actually potentially, because it's checking the amount that it's moving every frame, it could potentially jump over walls. So if your speed's like 100 and the wall's like 50 distance, you could potentially have the player jump over the wall. That's the only issue. And you would have to make some adjustments to account for that if you were going to have insane move speed. But for a top-down shooter, that's not going to be an issue. And you can go pretty fast without any problems with using this. All right, so we're drawing a blue square now. We don't want that. So what we're going to do is we don't want to change the player sprite because we're going to use that as the mask. What we're actually going to do is we're going to just draw the player. We're just going to draw the player sprite that we had before. And the advantage of this, if you run the draw event, it will no longer draw the sprite. So usually it draws the sprite by default, but if you have a draw event in your events, then it doesn't draw this anymore. So we don't have to worry about not drawing this. It won't draw this blue rectangle anymore. And we're just going to put in this draw event, what we wanted to draw, essentially, which is just the sprite. So we're going to use draw sprite extended. The reason we're using extended instead of just draw sprite is that extended includes rotation. And we want our player to be rotated towards our mouse. For the sprite, we're going to use SPR player idle. That's a sprite that we made. -1 for the sub image. The sub images is just what frame of the sprite. So when you have a sprite, you have a whole bunch of frames. Sub image is just the frame. -1 just means that it uses whatever frame it would usually use. So that means, yeah, if we do have an animation or a frame rate or anything like that, this will just use like what it's using previously. All right. Later on, if we were doing animations, we might have to change that later. But again, we're going to draw at X and Y. We're also, for the X scale and Y scale, that is how much it's stretching the image. So how much it's stretching along the X axis and how much it's stretching along the Y. We're using 1 and 1, which is no stretching. For the rotation, we're going to use that variable we came up with, angle. So instead of using image angle, we're going to use angle. And that's just to make sure that the collision mask doesn't get rotated. For the col is color. And we're going to put -1, which just means use the default color. And for alpha, we're going to put 1. And alpha is the transparency of the image. So if we put that to 0.5, it would be 50% transparent. But 1 is completely opaque, so not transparent. All right, awesome. And if we take a look at that, we should be pretty much where we were before, where we're drawing our sprite. You'll see that it doesn't fully line up because we are using the rectangular collision box. You can see we're kind of in the wall, but you can change that. You can change the size of the collision box. I do recommend using like a collision box. You could use a collision circle, but for this kind of collision, this is going to be absolutely fine. And we can shoot. It looks pretty good, honestly. Not bad at all. And that's going to just about do it for this episode of the tutorial. I hope you guys are enjoying the series. If you are, leave a like. Really appreciate it. Leave a comment as well. And yeah, I think in the next episode, we're going to I'll add some enemies, I think, is what we'll do. We'll add some enemies and make it so these bullets can actually hit and collide with the enemies and deal damage and kill the enemies. So that would be pretty sick. Yeah, all right, awesome. I'll see you guys in the next tutorial.